All set. I'm live. Y'all can see me on the internet. Oh man, this is amazing. Hey everybody, welcome to Commit Your Code conference. The first talk of the day is always the worst, right? So, put me first and get this. We'll get this party started. Hey, I don't mean to gloat, but I am a member of a very exclusive club. It's not the Finer Things Club. I'm a member of the I have accidentally spent way too much money on cloud club. Anyone else ever get an unexpected bill on your cloud compute? Azure, AWS, Google? No, just me? Couple? Yeah. Hey, should we play the game of the largest amount? All right, more than 10 grand? All right, so my highest is, what's your highest amount? 15? Okay, so mine was around 13, 14. Not for this talk, but yeah, that's a different talk later. The amount, well, let's say the amount of the mistake. Yeah. So we have a secret handshake that we do whenever this occurs. It's just, oh my gosh, where'd all my money go? And sometimes you can get forgiven, sometimes you don't. But yeah, I've always done this with client money, never with my own money, thank goodness, because it'd be a real pain in the butt for me. It's always with clients, and it's learning things the hard way. So hopefully for you all, you take some lessons from this and you don't make the same mistakes that I did. Let's talk about the story just going into this. I'm talking about serverless. I'm going to talk about Azure Functions in particular. And when we talk about serverless, and you hear people talk about serverless, it's generally as a very cheap thing. Like serverless is generally cheap. You can do a whole bunch of work, millions and millions of executions, and it's pennies to do these executions. So for a lot of different things that you would do in software, it's really cost effective to do serverless. Now I'm going to warn you all now, I have a very severe Azure bias. So I have used all the cloud platforms. I'm going to talk mainly about Azure because that's where a lot of my bread and butter is, but the lessons that we'll learn here today really apply to any cloud provider out there. So hi, everybody. If we haven't met yet, my name's Kevin. I'm the Microsoft guy in the room, other than Mr. Tim Corey back there. I love my .NET. I love my Azure. I'm the current president of the .NET Foundation, Microsoft MVP, all that good stuff. I love my Microsoft. If you ever want to talk to me afterwards, please feel free to hit me up on Blue Sky, not X, or LinkedIn, or go to my website. So everything I'm talking to you today is about lessons I've learned as a consultant, and this lesson in particular is from actually very recently. So let's start the mistake. Where did it all begin? It began when I learned about Azure Functions. That's the very beginning. We had an application, and generally what we do is we would have our main website, and then we'd have stuff in the background, web jobs, stuff, things that happen in the background. And every application has this problem. There's a million different ways to solve it. I actually do a talk on how to solve this 10 different ways in .NET specifically. And I'm not doing that talk here, but one of the ways that we come to solve this problem is take the main background jobs out of our application. It shouldn't be hogging resources from your main web app. It should be all stuff happening in a different service, different host somewhere else. And when I learned about Azure Functions, I took a lot of stuff that we were doing in the background of our app services and we're moving them to Azure Functions, which is really cool because we just do function A, function B, and it would just run in its own very cost-effective little host. And I learned about Azure Functions. We moved a bunch of stuff to it. I think the bill was like 3 cents. I'm like, oh man, I have a hammer and everything is a nail. Like I just wanted to put everything in Azure Functions, and I did. Like we just started moving all kinds of crap to Azure Functions. That ultimately led me to my mistake. I have a couple goals I want to achieve with the couple minutes I have with you today. The big thing is I want to talk about the promise of serverless. Like it was the golden child. It's supposed to bring balance to the force. Yes. And maybe if you don't understand how serverless works, let's talk about that too. Just it's very easy conceptually. We're not going to go deep in the code or anything, but we'll talk about what serverless is. And then we'll discuss when does serverless when is it a good solution? And then when is it a bad solution, or not the most optimal solution? So if I can answer those questions for you, we'll be good. The promise of serverless. All right. When I first started seeing serverless come into the ecosystem, I was one of these people who would sit there and go, it's just someone else's servers. It's not actually serverless. There's still a server there. Anyone else like that? That's the wrong way of thinking. That's a poor way of thinking, because it's so much more than just someone else's servers. There's infrastructure changes, there's architectural changes, and it's when I kind of got my head around how serverless works fundamentally that I really come to love it, and it became a hammer in my toolbox. All right, let's just talk about traditional application hosting. You have a web app, it could be anything. It could be .NET Node, it could be Laravel, it could be blah, 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 and your application does stuff. You have API calls, you have different functions. When you host this, usually you're putting it up on one of the hundreds of hosts that are available out there, and you're paying for some sort of reserved capacity just to have the app up and running at any time. So if your app is just doing nothing, which a lot of ours right out of the gate does nothing, you're paying for those resources. Awesome. Now, when your app is fully up to scale, you're getting millions of requests per second, like you're just kicking butt. Well, you're still paying for that capacity, and you might run up against just how much that one host can do. So what do you do when you need more capacity? Well, you scale up. So you don't have just one host, you have multiple hosts, and they're behind some sort of load balancer. Well, when this happens, and you're at crazy scale, you're paying even more amounts of money. Like, scaling costs money in general sense. So you just keep paying over and over again. Now, with functions, we're going to change that mindset a little bit. We don't have the traditional app host that we're used to. We're just deploying functions. A GET request for that, a queue processor for something else. We're just pushing individual functions. Now, behind the scenes, there is a host, there is a server, all that stuff's happening. But when nothing's happening on the server, your app's just sitting there dormant, and you're not paying for anything. It's just a fraction of a penny to just exist. But then when you get that crazy scale and the application is just going full blast, you're still just paying pennies because it's only running the individual functions. You're paying for just the function to execute. And this turns out to save you hundreds, if not thousands of dollars over the long run, because you're just deploying functions. You're not deploying entire applications. And you don't need reserved compute. You just use the compute at the time that you need it. So in general, this becomes a very cost-effective way to do a lot of different types of applications. So serverless, in a nutshell, just architecturally, two concepts. You have triggers, and you have actions. So something triggers a function to get executed. If you built a web API, you understand this. I make an HTTP call, something executes. But there's other types of triggers in the various cloud providers. Now, again, I'm Azure biased. We have a thing called blobs. It's like S3. You're putting files into a file system on the cloud. When that happens in Azure Functions, we can sign up for a trigger. I have a new file in my file system. I have a file was deleted, a file was updated. I can get these triggers. I can go execute a function. I use a lot of queues. If something hits a queue, I get a queue trigger. So I can go take that item off the queue, process it, rinse, repeat. And then we have very simple like HTTP trigger for webhooks and just simple API calls. Again, just execute a function. In terms of every cloud provider, I'm just glossing the surface. Like Azure has like a dozen or two different types of triggers that it supports out of the box. You can create your own custom triggers. Other cloud providers are the exact same way. Now, this is great fundamentally, but there's a time and place for serverless. And let's talk about where serverless works really well, and then we'll talk about how I actually made a mistake. So first, serverless is great when you have very short-lived execution life cycles for your functions. So The ideal serverless function runs within a second or two. Now, depending on the platform, depending on how you configured it, you can have functions that run up to 10 minutes. And actually, I have a lot of functions that run in simple consumption that can run for 8, 9 minutes, and they still cost pennies over a month. So it's not necessarily a hard, fast rule that they have to be quick, but it's usually better when they're fast methods that just iterate quickly. Because you're only paying for the execution time of that function. If it runs for 500 milliseconds, you're only paying for 500 milliseconds. If it runs for 10 minutes, you're paying for 10 minutes, but it's still pennies on the dollar. Yeah, up to 10 minutes. The biggest benefit for me with serverless was that I didn't have to write application ceremony. We've all gone through the exercise, file new, go to the command line, blah, 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 new, you create your templates. And all of our apps kind of start the same way. Maybe you start with a starter pack and you rip out all the crap you don't need, and then you start putting in the stuff you actually need. I don't like wiring up things like just basic web app crud. I don't like setting up queue listeners. I don't like listening to blob storage. I don't like listening to email services. I don't want to write all that stuff. I actually would wish someone would just tell me when something happened. And that's what Azure Functions does, or what serverless does. Tells you when an action occurs. It's a trigger. So when that happens, I just go write the code to handle the case there's something new in my queue. I also get the benefit of automatic retries. So your code is perfect, but other people's code isn't. So a lot of APIs fail for various reasons. Databases fail for various reasons. It'd be nice if something failed, if it would just try again automatically, and you didn't have to capture the error and then keep track of how many times it's failed. Retry code is hard, and a lot of us skip it. So wouldn't it be nice if the service would just do that for you automatically? And serverless does that in a lot of cases. Burstable scale. This is where I really come to love serverless. I do a talk called Annihilating Workloads, and it's about burstable scale, where my Azure functions could just sit there and do nothing, and all of a sudden, I start populating a queue with not hundreds, not thousands, but millions of entities that need processing. And that's not the type of thing I just want one little app to iterate through. I want cloud scale. That's what they promised me, was I would have this infinite container of servers to do my bidding. Burstable scale. I can go from 0 instances to 25 to 1,000 instances within seconds to just annihilate the workloads that I have. And it really is turning the knob all the way up to 11. And I have numerous cases where this has been amazing. There are also cases where this is not optimal. Number one, not every service out there is cloud scale. So while I might be able to handle thousands and thousands of entities at any one time, let's say I have a queue, I pull something off a queue, it goes to the database, does a simple CRUD action. Rinse, repeat, takes 500 milliseconds. That works really well, one at a time. Now let's scale that out to, let's see, 1,000 instances, all trying to do 25 items on the queue at a time. So 25,000 entities at any one moment. A lot of databases can't handle that out of the box right now. You have to pay for it usually. So most relational databases all work that way. I've taken down Mongo databases, hosted Mongo databases numerous times because it's just connections. I've tried to use more resources than I was actually paying for. So, I was on the wrong dot. So this is usually the limiting factor for us. We've had workloads where if we just left it alone, we take care of hours worth of work within seconds. But our database couldn't handle the connection load, and we weren't willing to pay for more database, or a bigger database, or a more performant database. Because that's where you really get into the tens of thousands of dollars, is a database that can handle cloud scale. A lot of APIs also have rate limiting built into them. We were learning this a couple of weeks ago with OpenAI. We were building some services on functions, and we were talking to OpenAI. We were hitting OpenAI rate limits. And it's like, all right, well, this is a problem. So we actually have to go into the configuration for our functions and say, don't scale so high. It's like only scale to a 5 and not a 25. So it really impacts. What, OpenAI?
Yeah, or it gives you an exception.
They throw an exception. Yeah, they'll usually throw a 429 rate limit. And if you have retry logic, it's really easy. You just go back in the queue and you try it again in a couple seconds. Yeah, it's not great when that happens. The other big thing in serverless is if you have high compute or high memory requirements. This is where my mistake occurred. So high memory requirement being, if I show you the picture from earlier of a simple Azure function, I can do millions of executions. It costs pennies to do that work. Now, this is consumption level pricing. This is what everyone talks about as this is the way of serverless. And this is great. But these little instances that you get are very compute restricted. They're also memory restricted. You can't do a lot in these functions because you're not supposed to. They're really just meant to go do a simple API call and return a response. We had to move the bunches of the Azure functions, and we were hitting memory limits. So we're getting out of memory errors. It was causing crashes in our system. Like, oh, all right, well, how do we fix this? How do we get a little bit more memory? And like everything in the cloud, you can pay money for it. So Azure Functions has a level called Premium, which is still consumption. You're still paying for the execution, but you get a little bit more reserved capacity. And they have different levels of this, EP1, EP2, EP3. And they have more memory, more compute, all that good stuff. So we ended up using EP2 for 7 gigs because we were doing a lot of stuff in memory. We needed the RAM. And at the calculator level, this isn't a big deal. Like one instance running at this is about $300 a month. I would gladly pay this any day of the week if this solves my problem. This is fine. But let's go back to how serverless works. A lot of what we're doing is producer-consumer pattern. So I have a queue. The queue has items in it, and our hosts take things off that queue to process them. Now, as your queue grows, we're producing more. It's called back pressure. And as that back pressure grows, the functions environment is going to detect that and go, oh, I really should give you more instances to handle that load. Azure's goal, or serverless's goal here, is just to get rid of that queue as quickly as possible. And all right, so it's going to keep iterating on creating these function hosts. And eventually, as more stuff grows, it's going to go up to whatever your limit is for instances. Now, the limit out of the box for a lot of this stuff is 25 instances. So that's what we were doing. We were putting stuff in the queue. It was processing that queue as quickly as possible. It got up to 25 instances at EP2. I shouldn't say EP2, not EP1. But there's a problem with this. Even though it annihilates the queue, the work gets done. It's great. But it costs a lot of money to run 25 instances for a month in Azure Functions and Compute. And this is where our $8,000 came from. And turns out, like, you see this, go, oh, that's a mistake. I could have solved this 300 different ways better. That would not have been $8,000. So at this point, we're basically just throwing money away on our application. So there are a lot of different ways to solve this problem. But if I had thought more about the workload that we were going to be doing in serverless, I probably wouldn't have solved this problem. The big conclusion you should take from this is serverless is a great solution to a lot of different types of problems. I still use it every day. I'm not trying to recommend that you don't use it. I do want you to avoid the everything is a nail problem. Like functions is my hammer. And I love using functions, but I don't use it for everything. And you shouldn't do that either. And the big takeaway from all this is you should really watch your bill. All the platforms have some sort of budget protection built into them. And my bias is showing Azure does this the best. Google does this the worst. If there's any Google people in here, I'm sorry, fix your problem. So yeah, check your bills, set out-of-pocket maxes so you don't go over a certain amount. Also look at cost analysis, where your money's going. And don't make the same mistake that I do. So thank you all for hanging out with me. I'll be out in the common area if you want to talk about any of this. And thank you. All right, cool. That was easy.